So, so just doing a recap, we just have to recap this one out, what we did here. So again, if you can see, uh, always start your solution with a table. A table that separates your horizontal and vertical quantities. Again, yeah. And the thing here is that only the quantity time you can use for both, okay? But you cannot use AY in your horizontal calculation. So that is why it's relatively important, because in some cases, some students will try to use the acceleration along Y in solving for the horizontal motion. But for horizontal motion, in a projectile motion, it's always zero. The acceleration is always zero. That's why essentially the acceleration of a projectile motion is just negative 9.8. And that is due to the fact that your AX is zero. So therefore, essentially, if you're going to get the magnitude of your acceleration as a whole, not your X and Y component, it just gives you the same thing, the 9.8 meters per second. Its direction is always downward. That's why we use the negative sign. And also for the position, especially for the Y position, remember, just to be consistent, I'm not saying that you cannot reverse or change your coordinate system. Just much easier to be consistent with this one, with the Cartesian coordinate system that we are familiar of. But in physics, as long as you actually have that definition in a particular problem, you can actually change it from one problem to another. But I just don't advise that one. Because actually I can also change, like I'm gonna make downward as positive. And actually we're gonna do that more in dynamics. Sometimes it's much easier to actually reverse or change our coordinate system. But at the moment, just stick with this coordinate system, be consistent, familiarize, and yeah. So if you can see here, if I use dy here as a positive 85, you can actually, when you try to solve that one, let's say, for example, in this case, if you forgot to place the negative sign here, you'll get a square root of negative, and you know that the square root of a negative number is not a real number. So your calculator will give you an error message, or there are some calculators though that it will give you like the imaginary number, or usually it is with like they place, let's say, what is the square root of negative 4. Square root of negative 4 is 2i. So some calculators will try to do that, but it's kind of odd. If you can see, oh, there's an I. What is that, an I? Well, yeah, if your calculator can actually calculate imaginary numbers, it will give you this answer here. If you get the square root of a negative number, okay? But in most calculators that I know of, well, it will give you an error value. So that is due to the fact that, well, yeah, maybe perhaps you use the wrong uh, value here, or the wrong notation for the signs. Because if I'm gonna make this one positive or negative, okay, this one here, if this is somehow okay, if I'm gonna change my coordinate system, it also means that I'm gonna okay, so yeah, so if I'm gonna change my coordinate system into positive, well, this negative 9.8 here will also become positive 9.8. But then again, just to be consistent, just use that one, and it should give you the same answer and correct answer as they are. So if you can see here, this is a particular problem that a single equation will not give you the correct answer right away. So you need to solve for the time first. And if you can see here, you use the vertical quantities to solve for the time, because essentially that's what is given in the problem. You're given at least 3 in the vertical motion. So therefore, I can solve the other quantities here. Even for the velocity along y, you can still solve, choosing the right displacement equation. And knowing that the time here is the same time that I can be used in the other side, now you have one additional, so that becomes 1, 2. Acceleration here is again 0, so that becomes 3. So still, uh, you use the displacement equation to solve for that. And essentially, if you can see here, for your horizontal component of your motion, the equation of motion is just this one here. All of the equations that you have in the displacement equation will just reduce into this one here. So Vx, dx, and time. So as simple as that. The basic equation for velocity, displacement over time. Okay, so let's move on to the next example. Okay, example number 4 is kind of different because you have here, it's vertically launched, vertically upwards with an initial velocity of 15 meters per second. Uh, for the first question, what would be its velocity at the highest point? Okay, so what would be its velocity at its highest point? Uh, if you're gonna somehow have a drawing out of this, so I'll be throwing this upward. Okay, it will reach at a certain height. Okay, so initially it's being thrown upward, so velocity is 15.0 meters per second. And again, using the same coordinate system, if it is thrown upward, this should be positive. So that's positive 15 meters per second. So for the first question, for letter A, well, even though you will not be, if you will not be necessarily computing this one here, what happens to the object at maximum height? Well, it is a point wherein it will start to move down also. That's the maximum height, the highest point, right? So this is always the case. At the highest point, the velocity is 0. Okay, but then again, this is just being thrown upward, okay? Because later on, if we're gonna talk about projectile motion, well, at highest point, actually the velocity is not equal to 0. Still moving, but it's just the y component. But in this case, it is just being thrown upward. So therefore, at the highest point, it is equal to 0. So automatically, at highest point, if it's just thrown vertically upward, so its motion is just up and then it goes back down. Later on, it goes back down. Okay, so at the highest point, its v is 0. It will stop first before it moves back down. what else? Well, for letter B, it's the maximum height. Uh, so what would be the position of this object here? So actually, you're looking at what would be the df here. Okay. So at maximum height, again, the velocity at maximum height is 0. So you're solving for df, or at least the final height. And based on the things that you know of here, I don't know the time.
Actually, that's wrong. Slide. Yeah.
Okay.
Yeah.
Okay. Yeah. Okay. Here. Okay. So if you can see here, I have VI acceleration, VF is also given. DF is I'm trying to get at least the maximum height there, but the final position, whatever the value there, I just take the magnitude of that. That should be the answer of the maximum height also. So I don't have a time component here, and if you're gonna examine your displacement equations, there's only one equation there that doesn't involve time, and that would be your VF squared is equal to VI squared plus 2A D or DF. Okay. So if you can see here, I don't know the time upon it reaches that particular height. However, I know the final velocity and the initial velocity, so that fits well on this particular equation. So final velocity is 0, vi is 15 squared plus the negative 2 times negative 9.8 times df of, well, I don't know that value. Okay, so this is 0 is equal to 225 minus 19.6 df. So if I'm gonna solve for df, I'll be subtracting both sides by 225. So this is 0 here, that's gone on one side. This is negative 225 minus 19.6 df. So solving for df, and if you can observe, as long as I use the correct notation for my signs, at least for my signs here, if you can see, it should also jive into my expected result. I'm expecting that it is above my initial position, so that should be a positive position, or DF, upon which, well, you have negative or negative, that's positive. So that would be 11.47 meter DF, or in 3 sig figs, that would be 11.5 meters. So this would be the maximum height reached. And again, when I say maximum height, remember that you set your VF, or the velocity, there at 0. So in some questions, it will not tell you what would be the velocity at that particular position, but if the question involves this, that at maximum height, automatically you can set your final velocity there at 0. Again, this is just for the case wherein it's being thrown vertically upwards. Okay. But anyway, we'll be talking, I think the next note template is on projectile motion at a certain angle. But at maximum height, that should be 11.5. So the question is, what will the ball's velocity when it strikes the ground? So let's just assume that in this particular case, we're talking about like the ball is thrown at the ground. So it goes up, reaches a certain height, but of course it goes back down. Okay. So in that particular case, like it goes up and then it goes back down to this the same. Again, let's just assume that the object is being thrown at the ground, starting from the ground, then it moves up and then reaches the ground at the same time. Okay. So how would you solve this question here? Well, again, you can write all the quantities that you know of. Well, you know that the initial velocity is given at positive 15.0 meters per second. Okay? The acceleration will always be negative 9.8 meters per second squared. And what do you think would be the position of the object? Well, is it not that we always set our initial position at 0 meter? And if you can see, if it goes back down, the position is also 0 meter. So that would be 0 meter. Again, if it goes back to its initial position, that means that that position is the same thing as the initial position, which is 0 meter. So you now have three quantities given. So again, as I mentioned earlier, if you have at least three, you can actually use either just pick and choose between the three displacement equation to solve for a particular quantity. We're being solved here, well, the impact velocity, so VF. This is the same thing as the impact velocity. When you say just before it strikes the ground, again, it's just the brink of hitting the ground, because you might be thinking that, well, if it hits the ground, it should stop. But then again, it's the time upon which just barely hitting the ground. Okay, so impact, we also call that one as impact velocity. So therefore, it's still moving. That's only my point. Don't take that one as for this particular question, because some students will try to take this one as, well, automatically they will say the velocity is equal to 0. But this, just take this one as the velocity of the object just before hitting the ground, or yeah, at the brink of hitting. So sometimes they use the term impact velocity. So what would be its impact velocity? So if you can see here,
any grade 10s looking to go retake, please go to the cafeteria now. Grade 10 to go retake to the cafeteria now. Thank you.
okay, so again, I can use VF squared is equal to VI squared plus 2AD, ADY. And the final velocity is the one that is being asked. Initial velocity is 15 squared. That's plus 2 times negative 9.8 times 0. So if you can see here, VF squared is equal to 15 squared. This is 0 plus 0. So therefore, if I can take the square root of both sides, that means that this is VF is equal to, I mentioned earlier that you have a plus and a minus there. And if you take the square root of a square, that just gives you 15. meters per second. But in this case, is it not that if it is moving down, the direction is downward? So therefore, you're going to take the negative value. Okay? So if you can observe here, the value is just the same magnitude. However, the direction changes. And actually, it's true for any position here. Like if you have the velocity here, I know that it is less than, let's say, it should be less than 15. So maybe if this is 8 meters per second, on its way back down, because it's always, well, it should always go back down. At that, the same position there, its velocity is negative 8 meters per second. Okay? So as you move out, it becomes lesser, but at the same position, as long as it is a position upon which it is also going from up or down, that means that it goes back to the same position. That would be a different case wherein if you have a cliff here and then it continues to move down. But in a case, if you can see here, if it goes back to the same position, their velocity, the magnitude is the same. The only difference are the signs. So if you can see here, one is positive, but one is negative. Negative because it's going down. So that means that if I have, let's say this one here is around 1 meters per second. So I would expect that at the same position, upon going back down, this is negative 1 meters per second. If you want to solve it mathematically, you can still solve them, but you should get the same answer. The magnitude would be the same. Well, not necessarily, technically speaking, it's not the same answer because the sign is different. So again, the negative sign here only indicates that it's direction downward.